Hey, what's up everybody? This is the Wheelman282 here again. Today's video we're going to be taking a look at power supplies for your retro consoles. So mainly this is going to be about how to build your own if you have a console that doesn't have a power supply. This is going to be how to build your own power supply for whatever console that may be. Mainly I want to go over some of the hazards to watch out for when you're building your own. It's not dangerous to you, it's more dangerous to your console if you don't pay attention to what you're doing, but otherwise it's extremely easy to do. So we're going to be taking a look at 4 power supplies a day, and they kind of all have their quirks. I just want to go over the quirks just to make you aware of some things to watch out for. So this is going to kind of be you have a console that doesn't have a power supply and you go to a thrift store and you need a power supply for it, and you want to build your own. You can pick power supplies up, or wall warts, whatever you want to call them, at thrift stores for $1 or $2. They're pretty cheap, and if you find one with a rating that matches your console but just doesn't have the correct plug, no big deal. You can fix that. We can make it work. So first, let's start off with the Sega power supply here. Specifically, this is a Mark 2103. This is for a Genesis Model 2 or a 32X. When I'm talking about all these power supplies, I'm going to kind of skip the input rating. If you live in North America, the input rating is going to be the same basically all over. If you live elsewhere in the world, it's going to be different for your country. So input rating is pretty standard for whatever country you live in. You probably won't find an overseas power supply, and if you do, it won't have the same plug type, so automatically it's different. But anyway, what we're going to be focusing on is the output and the polarity on these power supplies. So overall, this Genesis Model 2 power supply is pretty standard. This is what you'll find on most consumer electronic power supplies. Right here where it says output, this is 10 volts DC at 0.85 amps or 850 milliamps. So pretty standard output there, pretty standard rating. And if we look at here at the polarity marking, we can see that there is there's a positive in the middle of the plug, and then there's a negative on the outer jacket of the plug. And that corresponds with this guy right here. Positive in the center, negative on the outer jacket. Overall, this is pretty standard stuff here. Now let's take a look at the NES power supply here. So if you know anything about these NES power supplies, they actually output AC voltage, which is very hazardous to any consumer electronics, let's say a Genesis or whatever, if you plug it in. So let's see, output, it says AC 9 volts 1.3 amps. Yeah, so this supply outputs AC voltage, not DC. So if you plug in an AC power adapter to a DC electronics whatever, it'll destroy it. So yeah, you could not plug this into anything that accepts DC voltage. Most things don't accept AC voltage anymore. They did, some things did, like dial-up modems and NES, but overall that's kind of gone now. You will not find a modern day power supply that outputs AC voltage, more than likely. But yeah, this outputs AC voltage, 9 volts, 1.3 amps. Also notice there's no polarity marking on this. I mean, there really is no positive and negative. It's just AC. So just be aware of that. If you ever find a power supply that outputs AC voltage, maybe you can use it with your Nintendo, but that's about it. So now let's take a look at a couple more power supplies. Here we have a Super Nintendo power supply. So let's look at this one really quick. It says the output on this one is, let's see if I can read that, DC 10 volts at 850 milliamps. So that's pretty standard. But then let's look at the polarity marking here. You'll see it's different from the Genesis one. It actually has a negative in the center and positive voltage on the outer jacket. So let's take a look at the tip here. So yeah, in the center we have the negative pin, and then the outer jacket is positive. So that's kind of weird. You typically won't find those in either in this day and age either. So, you know, again, Nintendo and their proprietary crap. Yeah, so just be aware of that. If you find a power supply that fits your electronics, you know, and the voltages are right, make sure the polarity is right too. Otherwise, you can fry whatever you're plugging it into. Just be aware of that. And then, lastly, this is like my personal variable power supply. This is what I've been using with my Atari 2600 for a couple of years now, because I've just never had an official power supply. Still don't have one. But in today's video, we're going to be making our own. So with variable power supplies, they're pretty neat. You can output all kinds of different DC voltages. This one actually accepts 110 and 220 volts, 50 and 60 hertz AC, so that's pretty neat. You could use this in Europe if you wanted to. And specific to this one, you know, we have our voltage switch right here, and then we also have a polarity switch. We can actually swap polarities on this depending on what you're trying to power. So you can have center positive, outer jacket negative, or vice versa. Pretty cool. So yeah, this one came with, like, you know, a whole, see, it's 4, 5, 6 different plugs, and it's got all kinds of different plugs on this thing. So if you don't already know, Atari 2600 uses a 2-conductor phono jack like this one. So outer shield is negative, center tip is positive. So, you know, Atari 2600 connector. So, you know, it kind of leads us into the video. We're going to be building our own Atari 2600, you know, power supply. But it's not just for Atari 2600. You can use this video to construct your own power supply for anything, really. As long as you can find the correct plug and the correct rating on your power supply, you can you know, you can build your own power supply, and you don't have to pay out the wazoo for either a reproduction or an original power supply for whatever game console or electronics you want to, you know, power. So let's get on into it. So basically, this is my sacrificial power supply. This is some Acer crap. I think this came off of like a computer speaker or something like this. It says it outputs 9 volts DC at 1 amp. The rating on an Atari 2600 is 9 volts DC at 500 milliamps, so this will work perfectly. As you can see here, the plug on this is completely wrong, but that's okay, because we're going to snip this off and solder our own plug on. Also, you notice the polarity here. It says center positive, outer jacket is negative. Since we're snipping the plug off, it doesn't really matter. We can configure it whichever way we want. You know, you can swap that if you needed to for whatever your device you're powering, but in this case, you know, we're just going to build our own. So yeah, let's go over the tools and the parts you're going to need, and we'll get right on into this. Okay, so really quickly, let's go over the tools you're going to need. So first off, we have a multimeter here. You're going to need a Sharpie, some wire snips and wire strippers. This one does both, so I'm just going to use that. You're going to need some needle nose pliers, all of your soldering essentials, so your iron, solder, and flux. Helping hands are going to help out a lot. If you don't have them, it's not necessary, but you know, it'll help out. This will be pretty easy, guys. This is kind of a minimal tool set we got here. Overall, it's going to be a pretty simple process. So now let's go over the parts you're going to need to build your power supply. So first off, obviously, you're going to need your donor power supply. You just need to make sure it matches whatever specifications your piece of electronics needs. In this example video, you know, we're doing an Atari 2600. 2600 requires 9 volts DC at 500 milliamps. Our supply here, this is 9 volts DC at 1 amp, so you know, it'll work fine. The rule is, as far as voltages go, don't change it. Don't go higher or lower. For most intents and purposes. Sometimes it depends on the piece of electronics. Sometimes you can go lower, but it's, for all intents and purposes, have the same voltage. As far as amperage goes, you can always go higher, but don't go lower. So 2600s, they need 500 milliamps. This one has 1 amp, so we're solid. Next, you're going to need a plug that fits inside your piece of electronics. So with the Atari 2600, as I said before, it uses just a standard 2-conductor, basically phono plug. This is what you find on some audio equipment. So you have the negative and the positive tip here. And so this is just something I grabbed off eBay really cheap. This is, I don't know. This is just a pack of 2 I got. But anyway, these unscrew. We have our rubber jacket here, and then we can take the wire from our splice, splice it up in here in some sort of way where it's going to supply the correct polarity and everything, and then crimp it, and then put this back on, and then we'll have our plug for our Atari 2600. Pretty simple stuff, guys. So just grab the correct plug for whatever console you're using. Sometimes finding plugs can be a little bit confusing. When you're on eBay looking for the correct plug for whatever you're trying to power, like a Genesis or whatever, there's a couple of measurements you need to look for. This is kind of hard to find on the internet, so just kind of have to do some digging. But as far as determining the kind of plug that you need, there are 2 measurements to look for. There's an inner diameter, which is the diameter of the hole here, and then there's an outer diameter, which is the diameter of the entire plug. So when you're looking for a plug, just try to find the correct inner and outer diameter, and that will give you the correct plug, at least for barrel plugs anyway. Phono plugs, these are measured in millimeters, so naturally this is a 3.5 millimeter plug, and this is a 2.5 millimeter plug, and then these other 2, these are also barrel plugs, but they're just really small. So again, the diameter. But yeah, just be aware. There's different measurements for different plugs. So as far as barrel plugs go, look for diameter ratings. Phono plugs, look for millimeters. And you should be okay. But overall, just get the plug that you need. You could even grab it off another power supply that is either broken or it just won't work with your project. You could cut one off of an old power supply, splice it to the new one, and it would work as long as it fits. So you have options here. You don't have to go buy a replacement plug. You can steal one off an old power supply. So just be aware. But yeah, overall this is going to be a pretty simple project, guys. Not a lot of tools and not a lot of parts required. So let's go ahead and get started. Alright, so we're going to go ahead and get started here. So first off, we need to cut off the plug on our power supply here. I want to save this tip just in case I ever need it in the future. It's always nice to have parts laying around when you need them. So I'm going to cut this kind of long, maybe 5 inches or so, just so I can have it. I'll just cut it about right here. It doesn't really matter. So, the tip, don't really need it. It's just parts. So here we have our wire here. So we just need to go ahead and split this. About that much will be okay. And then we need to go ahead and get our wire strippers again, and we just want to strip some wire off of these 2 ends. At the moment, we don't really know what the polarity is on this. This wire here kind of has a dark marking on it, so I'm guessing that's positive, but can't say for sure without getting the meter. So I'm just going to strip these 2 really quick and test it with a meter to see what the polarity is. Okay, so there we go. Okay, so we're going to go ahead and test the polarity on this, and then we're going to use our Sharpie to mark the polarity so that we don't have to use the meter all the time. So we got it set to DC volts. I just want to measure if I get I don't know which one of these is positive, so I just want to measure if I get a negative or positive reading on here so that we know where we're at. So I'm just going to touch these 2 points here, and we get a positive reading. and that means that this is our positive line and this is our negative. So I'm going to go take my black Sharpie, mark that with a black line so that we know that that's negative. So you'll notice when I took the reading there, it showed about 12 volts, almost 13 volts. That's actually normal. For old linear power supplies, if they don't have a load attached to them, they'll actually read more voltage than they're actually rated for, which is normal. As soon as we get this fixed up and attach it to an Atari, the output will be 9 volts because it has a load. Unloaded power supplies, unloaded linear power supplies rather, can read above their rated voltage. So don't be alarmed, that's normal. Just take it as it is, take it as the reading. Now I'm going to take my casing here, or whatever you call it, go ahead and slip that on there. Don't forget to do that, that's pretty easy to forget. Just go ahead and slip that on there. And we just want to kind of see how we're going to fit this inside the connector here. So obviously we're going to stick it right here inside this crimp point, and these wires might be a little bit too long, but we can trim them. But I just kind of want to get an idea for what I'm going to do. So as you can see here, we have a hole inside the negative point here for the jacket, and then here we have a hole inside the positive point, or the positive pin, for the tip. So obviously we're going to put the negative wire on the bottom and the positive wire inside the tip. So what I'll probably do is I'll just stick it in there and bend the wires inside the holes, solder them in, and then close it up. Probably going to make these a little bit shorter though. I'm going to probably cut off, let's see, if I put that right there, I'll probably cut off about 25%. Just about that much. And I'm going to strip this again. Alright, so remember, this is our negative, this is our positive. So I'm just going to lay this in here. And I believe what I'll do, I think I'll just stick the negative wire inside this hole. Kind of bend it in a little bit. Give myself some room. Okay, so this is going to kind of be the idea. We've got the negative on the bottom, positive on the top. So I'm just going to kind of bend that in such a way where hopefully it won't fall out. Kind of like that. And I'm going to get my helping hands and we're going to solder this in. I'm going to apply a little bit of flux here. Help it flow into this the new metal here we have on our plug. Alright, so here we go. Okay, so there's that one. And we're going to flip this guy over. So we can do this bottom side. And gets the same treatment. Okay, so there we go. And I'm just going to inspect my work really quick and we'll move on. Alright, so I had to touch up my soldering a little bit. It didn't quite get on the metal, but we're good now to fix that. So last step is to go ahead and crimp the wire in. Not necessarily a necessity, but it's very good if you want your soldering not to break, pretty much. Tugging on the wires can break your soldering job, so I would highly suggest you crimp the wires in if possible. So I'm just going to take my pliers here and crimp these two guys in. Alright, and there we go. We got a good crimp job on that. Got a good soldering job. Just looked it over and made sure that nothing was making contact where it shouldn't, and everything looks solid. So let's go ahead and take our shield here, and depending on your soldering, it might not fit exactly, so I had to actually bend this top piece down a little bit just to kind of make it fit inside here, but other than that, it should fit okay. So we'll stick the shield on there, or the case, and screw it on. And there we go, guys. This is our Atari plug now. So I'm gonna go ahead and grab the Atari, and we'll plug it in. We'll test it out and see if this new plug works. Okay, so we're ready to test out our new power supply. So I've just got it plugged in here to a power outlet on the floor temporarily. So I'm going to go ahead and take the power strip or power adapter here and plug it into the back of my Atari. And it's got that weird 3.5mm power supply. And plug it again. And as you can see, it is working great. From what I can tell, apart from the interference and just this being an RF signal, I don't see any actual electrical interference being caused by the adapter. So, so yeah, I'd say this is pretty awesome. You definitely don't have to spend big bucks on an official power supply for whatever device you want to power. You can just build your own if you can find the correct adapter, and as long as you pay mind to the voltage, current, and polarity, and waveform, then you probably won't have a problem building your own adapter. So yeah, I'd definitely give this one a good thumbs up, guys. This is awesome. Definitely a money saver here.